is Nancy Leader on the Zeta Report.
The Earth wobble, in place since 2004, forms a figure 8 when viewed from overhead the North Pole. The polar push happens when the magnetic North Pole of Earth comes over the horizon, facing the Sun and Planet X. The North Pole then swings first to the right, then the left, and then bounces back, overcompensating before the next polar push. This is a daily affair. This can often be seen on weather maps, as in this map from January 2012, where the heat follows the slant leaning toward the Sun when the Sun is high over India. But during the swing to the left, Europe and the North Atlantic get more sun, as in this January 2012 map. The uneven melt in the Arctic is another clue to the wobble, as where the North Atlantic gets more sun, the North Pacific gets less. The polar push moves the North Pacific away from the Sun. The auroras, as recorded by NOAA, document this figure 8 wobble. The white map outlines are superimposed on the globe, so are not a precise indication of where these land masses lie, though they are a guide. The satellite goes over the polar regions every few minutes, with the path indicated by a black line. Comparing images taken 12 hours apart during July 6, 2013, we can see that the polar push where the North Pole of Planet X shoves the North Pole of Earth away clearly shows the exposed South Pole aurora stronger, while the North Pole aurora turns pale. But the opposite occurs during the bounce back, when the North Pole gets more sun than the South. Here the North Pole auroras are stronger. This happens daily, as the wobble is a daily affair. South Pole getting more sun. North Pole getting more sun. The Earth wobble can be discerned from long exposure photos that would normally show a perfect circle of stars moving around Polaris, the North Star. This shot from 2007 is nearly perfect, forming an oval rather than a perfect circle, but the wobble has gotten much worse lately. This long exposure taken in India on March 1, 2013 shows a tilt of the North Pole of Earth first to the right and then to the left. The North Pole of Earth is pointing at two different places during the night, neither of which is likely to be Polaris. Only slightly oval in 2007, pointing to two distinct places in 2013. As in this drawing showing how Polaris will not be above the North Pole as expected during the Earth wobble. What would cause a retrograde storm to pass from the east coast to the west coast of the U.S. on July 13th and 14th? The curl of the week-long storm is counterclockwise, like a land hurricane. Per the Zetas, this is an effect of the wobble once again. Part of the daily global wobble, the daily figure 8 assumed by the North Pole during the wobble, is a turn of the North Pole to the right and then to the left. What this does is first create a vacuum in the North Atlantic, sucking air from North America into the North Atlantic, and then pushing it all back into North America. This pull and push of air runs directly contrary to the Coriolis effect, which creates air masses in a clockwise manner in the northern hemisphere, up from the equator and round back again. Thus the retrograde flow of air east to west in a counterclockwise manner, all due to the increased Earth wobble. Zeta Talk. A personal best way of measuring the wobble is to see where the sun rises and sets, compared to expectation on planetarian programs such as SkyMap or Stellarium. This measure in Italy at 4:18 in the afternoon shows the sun much too far south. It should be azimuth 269, not azimuth 214. When it is late afternoon in Italy, the sun is high overhead in North America, tipping the globe so that Italy is tilted up. Thus, to look toward the sun at this time from Italy, one has to look lower on the horizon, more toward the south. Thus, the difference in azimuth. The direction the sun is shining can also be determined from webcam archives. This example from Colorado shows that the sun is rising sooner, higher overhead, and coming somewhat more from the south as the years pass. This comparison is between the same date and time, May 17th at 5:59 a.m. in 2008, 2012, and 2013. Note in 2008, the valley is not lit and the sun is low on the horizon, striking the main building toward the top but not lower down. By 2012, the valley is getting sun and sunlight is striking the main building at the center, not just the top. To show how the wobble has worsened between 2012 and 2013, we now see the valley well lit, but most evident, sunlight is striking the main building top to bottom. Higher in the sky is the sun and rising earlier in the day. Undeniable. Colorado was dropped lower in latitude during the Italy tilt of the wobble, thus giving it an earlier sunrise. But don't take my word for it. Check for yourself.
Until next time on the Zeta Report, I'm Nancy Leader.